It's easy to create a confidence interval for a sample proportion with the CIprop function. There is one required argument, x. The x argument is set equal to the nominal or ordinal level variable to be analyzed. The CIprop function has some standard optional arguments. With CIprop, you have options to weight observations, specify the dataset name, the number of digits to display after the decimal point, and whether you want the results printed to an HTML file in your working directory. The function also has a unique optional argument named level, which I will show you how to use in this video. The CIprop function can also show the confidence interval of a sample proportion on a plot. You can fine-tune the plot using CIprop's main, xlab, and xlim arguments. A couple of comments before we work through examples. First, notice that this function's name is capital C, capital I, prop. Most companion functions have capital C on the end, but this one has capital C and capital I on the front. Second, CIprop is designed to analyze the dataset variable, find sample proportions, and report their confidence interval. If you're given a sample proportion and a standard error, and so don't need to calculate those statistics, and you want to find the confidence interval of that sample proportion, you can use the sampdistC function as a confidence interval calculator. To see how the CIprop function works, let's work through some examples together. Let's use the CIprop function from the RCPA3's package to generate some confidence intervals for nominal and ordinal level data in a data set. To call this function, we type it in. By the way, I've already downloaded installed the RCPA3's package, and I've run the library command to load it, and I ran help CIprop to call up the documentation for the function so we can look at it and talk about it while we're learning to use this function. So the function has one required argument, x, and x is set equal to a variable in a data set that's measured at the nominal or ordinal level, so something that has categories. I'm just going to kind of pick out one at random here. How about agree facts? This is the how important it is for people to agree on facts. I'm going to stretch our table out here so we can see it without the lines breaking. So it reports the confidence intervals of proportions and 95% confidence intervals of the values of the NES agree facts variable, how important it is to agree on basic facts. So there are 5 different values in the data set, and it would make most sense if you look at the point estimate column first. So the point estimate is really the descriptive statistics of proportions. So 0.024 of the respondents say it is not important at all to agree on facts, moving up to 0.386 of respondents, or 38.6 of respondents, say it's extremely important to agree on facts. And each of these values has a lower bound and an upper bound based on the sample size and the point estimate. This can be seen in a plot where we look at the values plotted from not important at all to extremely important, and this part gets a little bit tricky because we're just seeing the dots here, and the markers are really big enough to cover the entire confidence interval here because the intervals are relatively small in this case. But we'll show you a way to look at it more closely. But before we do that, I want to add on the weighting variable in the data set, NESWT. Oops, not weight vote, I want WT. To weight these so our results are more nationally representative. I don't think it will have a profound difference on the results. Tweaks it slightly. I saw a slight movement in the markers here. Now we see the point estimates and have 95% confidence intervals for each of the responses. So that's the basic usage of the propc function. You just set x equal to nominal or ordinal level variable in a data set. The weights is optional. The data tag is optional, and it will generate a table of the confidence intervals for different values and a basic plot of those values as well. So we've used CIprop to create a table showing the confidence intervals for the different values of the dependent variable, as well as a plot of those values, which shows, although it's not very clear from the plot yet, we'll show the confidence bars horizontally around those markers. What else can we do with this function? Well, the documentation page lists out the options and the optional arguments. Like other functions in the package, you can use the data argument to name the data set, like name NES. We can say that the data comes from the NES, and if we do that, we no longer have to specify that in the X and W, and this should give us the same table. We get that same plot again, just the slightly different syntax that can be useful. It's really I think a personal preference whether you use the data tag or not. The digits argument, we've seen that before. You can change it from, the default is to report 3 digits after the decimal point, but you could do more than that or less than that. It also has the print C argument, which will output the table as well as the plot to an HTML file in your working directory. We've seen that quite a few times. Plot argument is default is true to create the plot, but if you just want the table of confidence intervals and you don't want it plotted, you could set the plot argument to false. Now, the standard is to plot a 95% confidence intervals, but you may want to increase that or lower it, or depending on your preference or the problem you're working on. For example, if you want a 99% confidence interval instead of a 95% confidence interval, you could use the level. You can use the level argument and set that equal to the desired confidence level as a percentage. So for a 99% confidence interval, I would add a comma and then level equals 99. Let's take a look. So now I get 99% confidence intervals, and those should be wider than the confidence intervals at the 95% confidence level. So those are 99% confidence intervals are now reported. So it can really be any number you desire there for the confidence level. And the plot sort of obscures the confidence intervals because by default the plot width is set from 0 to 1, really because the function, we don't know in advance where what data you're analyzing, and the proportions could be anywhere from 0 to 1. So we allow all that space to cover no matter where the markers actually fall. But in this case, the highest value, 0.378, it doesn't use much of the space, and so all the values that we want to see are less than, say, 0.4. So what we can do if we want to focus in the plot to see the markers more clearly and perhaps see the confidence bands, we can use the xlim argument to set limits for the x-axis. So by default, the limits are 0, 1. It should be written on the help file. Is it written? No, it's not. But by default, the limits of the x-axis are 0 to 1. That's what we're seeing, 0 to 1. But if we want to focus in more, we can change this. So I might say 0.4. And I'm picking 0.4 because I notice the upper bound, the highest upper bound is 0.392. That's less than 4. So if we plot from 0 to 0.4, we should be able to see everything that's reported and maybe see some things a bit more clearly. Okay, now not a dramatic difference, but if you look very closely at moderately important, very important, extremely important, you can see some bands that are extending from those markers. So that's the confidence interval. This data set is large, or relatively large, so the confidence intervals are fairly tight, but in this view you can see them more clearly. I'm going to do another example real quick that will, I think, show you another usage of the CIprop function and maybe help you understand the confidence intervals or proportions a little better. So I'm going to change this to NES death penalty, the variable in the data set that records respondents' attitudes or opinions about the death penalty. I'm going to take off the other optional arguments I had set for that agree facts variable. So let me run this, opinions about the death penalty, and you can see it plots 4 categories: favor strongly, favor not strongly, oppose not strongly, and oppose strongly, and then plots all those values. You might notice, looking closely at the upper bounds and lower bounds, that the widths of the confidence intervals can vary. So even though the same number of people were asked, the n is the same, the point estimates are different. And you'll see a slight difference where the estimates that are closer to 0.5, like favor strongly, will have a little bit wider of a confidence interval than responses that are further away from 0.5, like the oppose strongly category at 0.78. Difficult to see on the plot, but if you compare the numbers carefully, you'll see that. Now, the coding of this death penalty variable has 4 values, but there could be an instance where we're not particularly interested in whether the opinion is favor strongly or not strongly. We just want to know the proportion that favor the death penalty against the proportion that are opposed, and generate confidence intervals for the favor category and for the opposed category. What we would need to do is employ the transformC function that we first introduced in chapter 3, employ that on our variable to create a dummy variable for the CIprop function used. So I would say that the type of transformation is to create a dummy variable, and we will apply that to the NES death penalty variable. And the response, this part is going to be a little bit response that we want. You know, we can either choose to make the ones favor or oppose, depending on what, you know, we're more interested in. But for this example, I'm going to use the favor strongly and favor not strongly as the included category, the 1 category. So I'm going to make a measure of the proportion of people who favor the death penalty. Okay, I'm going to give this kind of a test run here to see if it transforms the variables as I like. It gives us this warning, make sure we're not overwriting data. We're not, because we're not saving it yet. Okay, so it looks kind of what I'm looking for. It's going through the existing NES death penalty data, coding some 1s, coding some 0s, and if there's not a response, it would leave it NA. So I'm going to now save the results of this. I will save it in the same data set, and I will call it death penalty favor. Kind of a long variable name there, isn't it? But it's descriptive, so we won't be too confused if we see it. And then we got a response, and that's looking good. And I'm going to just quickly change confirm to false, so I don't bypass that. I feel pretty confident in our coding now. So give this a run. It creates that variable for us, and I kind of see the new version of the NES pop up in our environment here. And so now that I've created this NES death penalty favor, I'm going to apply the CIprop function to the new dummy variable. And give that a run, and we've got the confidence intervals, the proportions. The 1 we know is the favor category. All told, 0.623 of Americans favored the death penalty and 0.377 oppose. And both figures have confidence intervals. And if you look closely at these confidence intervals, because it's a binary variable now, they will have the exact same margin of error. So the width of both confidence intervals are the same. The confidence intervals just center on different point estimates. And the excellent argument is useful again to focus in on, if we like, just a limited area of that plot. If we notice, the lowest part of the lower bound is 0.36, the highest part of the upper bound is 0.663. So we could have an X limit if we want to focus in on the relevant areas that is low as 0.35 and as high as 0.65. Okay, so that gives us a new plot. I'd really like to use the main argument to make a shorter, more concise main argument. That's getting awfully long, isn't it? But in any case, it's plotting our one category, the favor, and we can see the small confidence interval around that estimate, and plotting the oppose estimate from the sample and the confidence interval around that estimate. So that's, if you want to focus on two categories and report either, the confidence interval for the proportion that favor the death penalty, or conversely the confidence interval for the proportion who oppose the death penalty, that's how you do it. You need to use the transformC function first to make a dummy variable, and then use the CIprop function and apply that to the dummy variable. The CIprop function, as we saw earlier, can be applied to an ordinal variable or a nominal variable with more than one category, in which case it reports all your point estimates and their confidence intervals. Or you can collapse it further if you want to make a simpler binary category. But if the variable isn't already binary, you need to do that with the transformC function. It's not too difficult. There's just an extra step involved.